Welcome back to a new session. This will be the last and final video on the topic of factoring a quadratic equation. I handpicked some problems that are so unique, they look so different that you don't think they even belong in the category of quadratic equations. So that's the type of problems we're going to look at. And of course, I chose a couple of problems that we have done before just to reinforce the idea of how we went about and solving those. So without further delay, let's get started. So the question has given you an expression and asks you which one of the following statement correctly describe its solution set. So whenever you are talking about rational, imaginary, or distinct, we have to use the discriminant concept we've discussed before. So to solve that, 6x squared equals 5x plus 21, which is same as 6x squared minus 5x minus 21 equals 0. We know this is A, this is B, and this is C. So B squared minus 4AC implies it's negative 5. So in other words, I didn't write it down. A equals 6, B equals negative 5, C equals negative 21. So B squared minus 4 times 6 times negative 21. All of this comes down to 25 plus 4 times 6 times 21. So let's do the math here. 4 times 6 times 21 plus 25 is 529. Okay, let's see if you can take the square root of it. Yes, if you take the square root of the discriminant 529, you end up with 23, which is a perfect square, right? If it's a perfect square, it is rational, okay? And we don't see any discussion about distinct here, so we can disregard that. There is a couple of choices that ask whether the solutions are imaginary. The fact that the discriminant is non-negative, okay, non-negative, therefore imaginary is out of question. Okay, imaginary is not possible. So any choice with imaginary is out. And because we already said it's rational, anything with irrational is out. And it's asking exactly one solution, which is rational, exactly two solutions, both of which are rational. Whenever you take a square root, you have plus and minus 23. Rational numbers can be plus or minus or 0. So that means you can have plus 23 or minus 23. Hence, the correct answer is exactly two solutions, both of which are rational, and we can cancel this out as well. All right. So whenever you hear quadratic equations in terms of rational, distinct, and imaginary, or real, those sort of things, then you have to use the discriminant principle to arrive at the final answer. So let's continue our discussion further. This is a different type of problem. So we have 3x squared plus 7x equals some unknown value, right? Fill in the blank with the real constant to form an equation with exactly one real solution. So what we can do is, let's assume that unknown value to be A, or actually, let's assume it to be not A, because we will run into a confusion between B, A, and C. So how about M? Okay, how about M? So that means 3x squared plus 7x minus m equals 0. Now this is a quadratic expression in which A is equal to 3, B is equal to 7, C is equal to negative m, right? Right? So B squared minus 4AC would be equal to, B squared is 7 squared minus 4 times 3 times negative m. Let's say this is equal to 0, okay? That means 49 minus of minus, which would be plus 12m equals 0. 12m equals negative 49. So m is negative 49 over 12. So the key here is you have to first assume a value and then equate the discriminant equal to 0 and then solve for whatever the unknown value is, and that's it. All right, let's do one more problem on this concept. So here, again, we have x squared plus 16 equals 7x. We don't know what this coefficient is. Let's again assume it to be mx squared plus 16 equals 7x. We can rewrite it as mx squared minus 7x plus 16 equals 0. We know this is our A, this is our B, this is our C. So A equals m, B equals -7, C equals 16. So B squared minus 4AC equals 0. So B squared would be -7 squared times 4 times m times 16 equals 0. So 49 minus 64m, right, equals 0. -64m equals -49. The negative cancels out. M equals 49 over 64. Can you reduce it any further? Well, we know that 49 goes by. No, we can't reduce it any further. Can we? I don't think so. 7 can reduce 49, but not 64. Similarly, 9 can reduce, no, not even 9 can do it. So let's see, we can do 64 by 3. No, that won't work. So we can't reduce it any further. So that means this will be it. All right. All right, I love this problem because, again, if you make the assumption, the problem is very simple. I'll tell you what that assumption is. Tommy throws a rock off a 10-meter ledge at a speed of 3 meters per second. Calculate when the rock hits the ground. So basically what's happening here is, if this were to be, Tommy is standing right here, and so this is 10 meters. So we know the height is 10 meters. This is where he's standing. This is ground. Okay. He's standing right here, so it's 10 meters above the ground. From here, he throws a rock at a speed of 3 meters per second. We don't know whether he threw it up and he came down, or he just threw it. So let's just draw something like this. Okay, we don't know whether he threw it far in the sky, or he just threw it, or if he just dropped it from there. We don't know. Let's just assume, but it doesn't matter. We have a formula. So it's asking, calculate the time when it hits the ground. So it's asking t equals what? It's not asking what the distance is. Well, it has to come down 10 meters for sure, but we don't know anything else. That's why they safely ask you the time. So we know some information. We know gravity. We know the speed. We know the starting height. So let's assume this 4.9 to be 5. Again, this problem is part of the use of calculator section, so you don't even need to do that, but it still makes your life very simple. So gravity is 5 and speed is 3 meters per second and height is 10 meters. Okay, if you put it all into this expression, S of t equals -5t squared plus 3t plus 10. We'll get rid of the units here. So this equals to 0 because it's getting back to the ground. You can rewrite it as 5t squared minus 3t minus 10 equals 0. So let's use this. We can just solve it with conventional factoring. We have to use the quadratic expression minus b plus or minus b squared minus 4ac over 2a. So that means it's plus 3 plus or minus 9 minus 4 times 5 times -10 over 2 times 5 is 10. So that means it's 3 plus or minus 9. And this is 10 times 5 times 4, 200 plus 200 over 10. So it'll be 3 plus or minus square root of 209 over 10. So if you take the square root of 209, like I said, this is part of the case where you can use your calculator. So you get about 14.5. So it's 3 plus or minus 14.5 by 10. If you do 3 minus, we can split this as 3 plus 14.5 by 10, R3 minus 14.5 by 10. Right away, we can cancel this out because time cannot be equal to negative. So that means it will be 17.5 over 10 is 1.75 seconds. That is it. Very, very simple. But again, calculator helps make this problem much simpler than what it would have been. But again, this sort of problem typically comes under the use of calculator section on the SAT exam. So nothing to worry. It's a pretty straightforward quadratic problem. So let's move on to the next problem. Okay. A farmer has a 44 feet of fence and wants to fence in his sheep. He wants to build a rectangular pen with an area of 120 square feet. Which of the following is a possible dimension for a side? Now the 44 feet is actually perimeter. If you carefully read it, a farmer has a 44 feet of fence. That means it's talking about the entire length of the fence covering the outer area of the farm that he has. So that means we don't know what X and Y. We don't know what the length and width is. That's what it's asking for. So let's assume it to be X and Y. So perimeter of the farm is 2 times X plus Y equals 44. Okay, for convenience, I'm not including the units. And area of the farm is X times Y equals 120. Okay, this implies 2X plus 2Y equals 44, right? And we can say XY equals 120, or you can even reduce it even further, you know? It's totally up to you. And y, we can substitute either X or Y in place of X or Y. So let's do X equals 120 over Y. If you take this and put this into this expression, then you get 2x plus 2y equals 44, right? That means 2 times 120 over y plus 2y equals 44. So that is, if you take y as a common factor, that means it's 240, right? Plus 2y squared equals 44y, right? If you take y as a common denominator. This further reduces to 2y squared minus 44y plus 240 equals 0. We can take 2 out of the expression, so it's minus 22y plus 120 equals 0. And 2 is irrelevant. To get plus 120y squared, and we also have to get negative 22y, but we can do negative 12y times negative 10y. I'll give you this at the same time, negative 12y minus 10y equals 120, sorry, it will be negative 22y as well. So that means if we substitute this, let's do the math here. So it'll be y squared minus 12y minus 10y plus 120 equals 0. We split this here, it'll be y minus 12 minus 10, y minus 12 equals 0. Y can be 10 or 12. 12 is not an answer choice, so 10 is the one. We don't know whether, if you had assumed, they didn't ask you specifically which is which, they're just asking one of the two values. The other value is not given. This means the answer is 10 feet. Okay. Let's solve this problem. This looks very confusing, but it's not. It's just good old quadratic expression. So let's write this expression as 18x squared minus 39x minus 84 equals 0. We can take, I believe, 3 out. So that means we have done a problem before. 3x squared minus 13x minus, I believe I said it's 84. 84 over 3 is 28. So 28 equals 0. We can disregard 3. So it's 6x squared minus 13x minus 28 equals 0. 28 times 6 is 168, right? 168. I believe I said it's 21 times 8, so negative 21x plus 8x minus 28 equals 0. Remember, we want negative 168x squared, right? So if you multiply negative 21x times 8x, then you get this. Similarly, when you add these two, then you get negative 13x, and that's exactly what I did. If I split this in two parts and I take believe 3x out of the bracket, I can get 2x minus 7 plus, I believe I can take 4 out, which will give me 2x minus 7 equals 0. 3x plus 4 times 2x minus 7 equals 0. X equals negative 4 over 3. X equals 7 over 2. All you have to do is figure out which one will give you these two, right? This would be negative 3 times 2 is negative 6 plus 1 is negative 5 over 2. So this can be right. This would be negative 3 plus 1. That won't work either. What about this? Well, let's do one of these. For sure, it'll be 3 times 2 is 6 plus 1, 7.5. And this would be negative 3 plus 1. That won't work. Negative 3. This equation, I don't think it's got a solution. I don't see any of these turning out to be this. So 3x plus 4, negative 4 over 3. 3 times 6, 4, 5, 6, 5. Well, part of it is telling me there is a solution, but part of it's telling me there is no solution. This works. Let's look at this. Negative 3. Oh, actually, you don't include the negative in here. Sorry, I was getting carried away. The negative is not part of the multiple. So what I'm trying to say is you have this, right? Sorry, I had a little lapse of concentration there. So 3 times, you multiply 2 times 3 plus 1 over 2 for this one. That will give you 7 over 2. Okay, this negative is not part of this expression. It's only this that works. So 3 times 1 plus 1 over 3. The negative is just outside. So negative 4 over 3 and 7 over 2. So it's this. I don't think any of the others will work. I can tell you that. Okay. See, even with doing as many problems like I do, you can still somehow have this, blank space in your mind. So you have to focus and make sure you double check your work 2 times, maybe 3 times. Here, I could have easily chosen the equation as no solution because I could have got carried away with the negative, and that's not true. So learn from me, okay? You can make a mistake, but make sure you correct. All right, 2 consecutive positive multiples of 3 have a product of 504. Now, we've done similar problem before, but those numbers were really, really small. When you have to do something big, of course, you can sit and figure out all combinations of 3. So you could do 3, 6, 9, 12, 24, sorry, 12, 15, 18, 21, 24, 27, so on. So which 2 numbers will, well, I know for a fact 21 times 24 equals 504. Okay. I don't think anything else within this range will give you that. If you're unsure of doing this method, there's another method that you can do. Because it says positive multiples of 3, if the number is 3, then its multiple is x plus 3. Now this is equal to 504. And if you do x squared plus 3x equals 504, do you see why I got x times x plus 3? If x is 3, the next is x 3 plus 3. And because it says the product is 504, I am multiplying those two. And x squared plus 3x minus 504 equals 0. We want negative 504 x squared, which is same as 24x minus 21x will give you 3x. 24x times negative 21x will give you negative 504x squared. So x squared plus 24x minus 21x minus 504. And if you solve for it, you get x plus 24 minus 21 means x plus 24. So x equals 21, x equals negative 24, okay? But again, if you solve this way, you would wonder, well, I'm getting a negative value. How does that factor into the problem? Well, you have to assume it's an absolute number, right? Because it's a positive multiple. So that means you have to assume this is an absolute value. That means x equals plus 24, okay? Only then you get sum of the two numbers would be 21 plus 24 would be 45, right? If the question didn't say positive, then yeah, we're in real trouble. I don't think you can solve the problem, because when I did this version here, it seemed really straightforward. Everything is positive. Whereas when you did the quadratic expression, you see one of the number is negative. But because it's positive multiple, it has to, you can assume it to be an absolute value or treat it as if it is positive. Then you get x24 and you add it, you get 45. Okay, let's do one more problem. And I think this is the end of this series of videos on factoring quadratic equations. Two consecutive positive numbers as a product of 420. So let's assume the first number be x and its consecutive would be x plus 1, right? If it's 2, the next number would be 3. So the product of those two would be equal to 420. So x squared plus x equals 420. So x squared plus x minus 420 equals 0. We now know 21x, okay, minus 20x minus 420 equals 0. So x, right? 21 times 20 is 420. Don't believe me? Go ahead and give it a shot. X plus 21 minus 20 times 21. If you take 20 out of the bracket, and it's x plus 21 equals 0. X minus 20 times x plus 21 equals 0. Again, we have the same problem. One x value is positive and the other value is negative, but we're going to assume as if it's an absolute value, which means x is plus 21, and you add the two values, 20 plus 21 equals 41. This problem can only be done this way because, well, it's going to take you forever to figure this out. Or you can write 1, 2, 3, 4, 5, 6, and all the way. You would eventually figure out, yeah, it's 21 times 20. But again, you need to have a backup plan so that you can do well on an exam. We're not just solving problems and go on to do other things. We're doing problems because we're preparing for the exam, so we have to have a backup plan. What if this doesn't work? I need to have alternate way of solving the problem. And that's why I chose these problems, which are very similar to the problems we've done before. They're not different, but they have a different take that was not present in the previous version. So that's why I chose to do it. And I do have an additional problem set on quadratic equations, which I'll make a separate video. But as far as factoring quadratic equations, this is the final video. And if you've learned something, please subscribe to my channel, like the video, and please share it with your family and friends. Thank you for watching. I'll see you with another video on the heart of algebra topic. All right, so stay tuned.